Okay, so you need to go to the coursework. Yeah, last time we discussed about 5.3, right? Okay. So today I will continue. Okay. Yeah, don't forget to do the particular the course evaluation. Okay. Let me see. Um, no, not this one. Okay. Yeah, I will put the course evaluation later. Okay. Or you can go to here. Okay. And then take the course evaluation. Okay. Okay. For today, I think I can go to. You can go to the course coursework and go down to 5.4. Right. So this will be the last section, right? Okay. We're talking about the data clustering with R. Okay. Hmm. Let me see here. So how many questions? Yeah. Yeah, only three questions. Okay. So you have to read the slide from the reference 2 and reference 3 and chapter bit from the reference 3. Right? What is a cluster analysis or clustering? Explain and give an example. Right? Okay. So yeah, I give you the link down here. Particularly, you can also check it from here. Um, oops, sorry. Okay. Coursework. Oops, sorry. Mm, yeah, unit 3, unit 5. So you can do this. Yeah, so talking about data clustering, right? Okay. Okay, introduction. And what is data clustering? Data clustering is to partition data into groups, right? Where the data in the same group are similar to one another, and the data from different groups are dissimilar. Okay. So this based on the reference that you can find from the slide. Okay, so and then to segment the data into clusters so that the intra-cluster similarity is maximized and the inter-cluster similarity is minimized. Okay. And the group obtained are partition of data which can be used to customer segmentation, documentation categories, categorization, and so on. Okay, and so this is using the clustering data. We use the key mean clustering. Okay, so using this command here, and yeah, you can go to the program. Okay, So yeah, there are many clustering here. I think we only discuss about the K-mean, I think. Okay. Let me see. Okay. Go back to the problem here. Sure. So what is cluster analysis or clustering? Explain and give example. Right. So uh, reference 2 and reference 3 and the chapter A from the reference 3. Okay. So you can go here. Yeah, you can conclude from here. Okay. So you can there are yeah, you can read here. The context of the clustering analysis is the study of technique for finding the most representative cluster prototype. Right? So you can consider as summarizing or compression or finding the nearest neighbors. Okay. So it's explained here first what is the cluster analysis. Okay, you can read this one. Okay, so there are different type of clustering like hierarchical versus partition. Okay, and exclusive versus overlapping versus partition and all that. Okay. Uh, complete versus partial. Okay. And there are different type of clusters, which are like well spirited or prototype based or graph based or density based, right? Or shared property conceptual cluster. And yeah, so this one of the we call it a prototype based partition clustering technique that attempt to find the user specified number of clusters which are represented by their centroids. Okay, and there's another type of clustering because it's agglomerative uh, agglomerative hierarchical clustering, okay? Or DP scan something like that. Okay? So this is the sample here. So this we call it dual spirit cluster, and this is we call it center based cluster. Okay, and this is we call it a continuity based cluster. This one is clustered to at least one point in its cluster than to any other point in another cluster. Okay? And this one call it a density based cluster. So the highest density separate with the low density. Okay? And this is conceptual cluster. So point in the clusters share some general property. Yeah, so this is more detail about what does it mean. Okay? And this is the algorithm for the k-mean. Okay? So assign points to closest centroid. Right? So for example, this closest centroid here, so all of the points that is close to here, we will cluster to this. For example, you divide the three clusters, so you have three centroid, and the data will cluster around this centroid. Yeah, so you try to read that reference. Okay, so you can answer number one using the example that you saw from this textbook. Okay? Yeah, so that's number one of it, right? What is clustering and explain and give an example, right? So you can pick one of them, and also you see there is a what you call it, the k-mean clustering, right? So you can read it also from the reference that I show you. Okay? And what is the algorithm? So the algorithm will be, oops, sorry. Let me see. This one. Yeah, I think I need to close this. This is from the what do you call it? From the yeah. So yeah. So the k mean clustering, right? So you need to read this, or you need to read this one to understand what is the k mean clustering, right? Okay. So no, what was I say? Mm, yeah, you click this one. You click this, it'll give you the reference for this one, right? Yeah. So answer number one, number two is from this reference. Yeah. And for number two, the answer should be this one. Yeah. So the answer should be in here. So the k-mean method is defined a prototype in terms of centroid, which is usually the mean of a group of points, and is typically applied to objects in continuous n-dimensional space. Yeah, so for the k-mean, so the algorithm will be this one. Right? So for number two, the algorithm will be this one. The definition will be, you can conclude from here. Okay? So that's number two. And number three, you need to run this program. Okay? Uh, yeah, maybe I need to keep putting the link here so you can, so you don't need to looking for anywhere, right? Okay. Yeah, let me put the link there. Okay. So you don't need to look in anywhere else. Let me see. So go to test folder, and I need to put the link to the online program, right? Okay, so I'm going to put up here. Yeah, I have to make sure the link is in new window. Okay. Okay, I put this. So the total point is, yeah, here be careful. The total point is like 14. Okay. Okay, let me see and get into test folder. Okay, so I'm pretty sure this test. So already put it there. Okay, so the link. Okay. Uh, Maybe I need to also put this in the other section. Okay, one more problem here. Okay. Yeah. So you need to click that link and then go to the program, right? Okay. You can erase this and then put the comment here. I think it starts from this thing. Copy and then paste it here. Yeah, you can also go to the go to the um, go to the slide. Okay. So they came in and then this is the midway cluster. Midway clustering. Yeah, I think they explain about the algorithm. Okay. Uh, yeah, so this came in algorithm. So this is like this. And so first is you set the seed, right? For the random number generation to make the result reproducible. Okay. So this is uh, the first, what do you call it? The first thing that you need to do is set a seed of set a seed for the random number generation. Yeah. And then the second one is make a copy of the arrays data, right? So copy the arrays data to arrays2. Okay. And then uh, removes the class level species. Okay. To 0. Okay, and then what is this here? And then the run k-mean clustering to find 3 clusters. Okay, and then save the result to k-mean dot result. Okay. And then print the clustering result. Okay. And give you this one, this output. Okay. And then put in the table. So in the table. Um, and then plot using this. Yeah, I think this one give you this one, and then this one give you. Yeah, so let me run the program. Okay, so what happened? Okay. I think it will be like that. Okay. Let me run the program. Okay. Okay. What happened here? The result of gaming clustering table. Okay. Okay, I think I missed one more parenthesis here. Okay. Let me fix the problem here. Yeah, I think I missed one more parenthesis here. Okay. Let me fix the problem here. Yeah, I need to put one more parenthesis. Okay, so number 3 will be, we already put the parenthesis there. Okay. So what happened here is first you need to create the SCC and the SCC and the what do you call it? And the slide. Right? This one is slide. The slide is this one here. Okay. So first is uh, set a set of random number generation to make the result reproducible for the k-mean clustering. Okay, and then make a copy of the arrays data. So you copy the arrays data to the arrays 2. Okay, and then remove the cluster label species. Right. Okay. So you only put what? As a 0, that means if you put null here, that means you replace the species with empty data, right? So this is the way to remove the class label species. So you only run for the what? Simple length, simple with something like that, right? Okay. And then run the k-mean clustering to find 3 clusters. Okay. So this is the command. And then print the clustering result. Okay. Using k-mean result. Right? So it gives you this one here. Okay. And then the next step, table, give you this table here. Okay. So check clustering result plus label space, yes. So this is the clustering result again the class labels space, yes. Uh, so you can see the cursor is in the first cluster 0, and in the second cluster is 50, and then the third cluster is 0. Right? And particularly there are 2 in cluster 1, 0 in the cluster 2, and then 48 in the cluster 3. And for the Virginica, 36 in the cluster 1, and then 0 in the cluster 2, and then 14 in the cluster 15. Right? Now you use the plot, it'll give you this one. Right? Okay, let's see here. So you can see the plot here is first is you plot the what do you call it? the You can see the different. Yeah, I think the last statement here print the point. Okay, the point is this one and this one and this one. Okay, so you can see it as if you put the stack there and run it. You will, I believe you will not see the points. Okay, so you can see the point, right? Okay, so this is like the point for the mean. Okay, then you can see the point again. Yeah. Okay. So this one is plot the cluster centers and also the point. Right? Okay. So yeah, that's it, right? So do you have any question? Let me stop from here. Okay.